Hello again and welcome to part 3 of section 3.2. Let's just jump into things here. I think we can wrap things up in one video for you. And this says to write the number as a fraction. Alright, well, it's 3 3/4. And what you need to do here is basically change this from a mixed number to a fraction. So let me give you a little reminder here. If you got 3 3/4, one of the tricks, you can make a check mark. Multiply 3 times 4 and add 3. Okay, 3 times 4 plus 3. You take the whole number times the bottom number and add the top number. So you see what I'm doing there? 3 times 4 plus 3. Okay, it's like a check mark. See it? Check mark. Check X plus 3 times 4 plus 3. Anyway, 3 times 4 is 12. 13, 14, 15. That's 15/4. Is my fractional value right there. Well, how about -9? How would you write that as a fraction? Well, that's simply -9/1. That's all you need to do there. And number 3 over here, do your check mark trick. 1 times 4 plus 3, right? -1 times 4 plus 3, so it's going to be -4, 5, 6, 7, -7/4. -7/4, right there. So yeah, that's all you do to it. You do need to know how to change a number from a mixed number into a fraction, or if it's a number without a denominator, it's always a 1 on the bottom there. All right, number 4 here, it says write each decimal as a fraction or mixed number in its simplest form. Here, well, you're gonna have to know your place values here. The first place value is tenths, so that's tenths. The second place value is 100ths. So this is 7/100. 7/100ths is what that equals right there, because it's tenths, and this one is 100ths. And if we go out another one, it would be 1,000. All right, number 5, I'm going to make a slight change to. Just ignore that, and let's rewrite it as just -3.85 without the repeating bar. Because honestly, that repeating bar it's a little crazy, and I just don't want to get into that right now. That's something you might do later, but I really don't think we need to do it. For now, what I would like is that you could take that and turn it into a mixed number. So it's -3 wholes, but you have 85/100ths. 85/100, which you have to reduce 85/100ths by dividing out the factor of 5. 5 goes into both of those, so that reduces down to -3, and I wrote it down over here, and 17/20. Now you might be wondering, where did I do that? So let me make a note down here for number 5, because you've got some workspace here. Okay, it says I had 85/100ths. And I know that 5 will go into both of those numbers. So what I did is I just divided them each by 5. 85 divided by 5 was 17. 100 divided by 5 was 20. That's where I got 17/20ths. Okay, number 6, how about I just do that one down here? So I don't like how this paper's laid out. Okay, again, I want to do the same thing. Instead of saying it with a bar, let's just call it 0.78. Okay, tenths, 100ths. So it's 78/100. All right, well, that's got a common factor of 2, so I'm going to divide that by 2, and that's equal to 39. And that's 100 divided by 2, and that's equal to 50. 39/50 is what that equals right there. 78/100ths is the same as 39/50 right there. And number 7, says there are approximately 2.54 centimeters in 1 inch, so express that as a mixed number. Okay, well, it's tenths, 100ths, so it's 2 wholes and 54/100ths. Okay, so that's equal to 2. Well, what you've got here is you've got a number divisible by 2 and a number divisible by 2. 54 divided by 2, that would be 27, and 100 divided by 2 would be 50. So you have 2 and 27/50ths there. And that takes care of number 7 for us. And then we can wrap up the last one right here. It says identify the sets, and this is what I definitely want you to focus on, that you're able to do, as well as the other stuff, but hopefully that is more review for you. It says identify the sets which each number belongs to. Okay, so look what we have here. We have that picture that we did on the previous page. I wish I would have printed that picture on this page for you, but you can just flip back to it. Now I'm going to do a nice little smart trick here for number 8, and here's what you have to do is you have to name all of the different sets that each of these numbers belong to. So number 8 says -632. So here's how you think. Okay, you take the number and you start on the outside, and you ask yourself, does this number fit into this group here? Is -632 a rational number? Well, yes, it is, because it terminates. So it would be included in that. So let's see. I'm going to do something here. I'm going to make it a little bit smaller. Hopefully you can still see that. Let's see if we can slide that up into this group right here. -632. Would that be in the set of integers? Take a look. If I kept going -1, -2, -3, -4 forever, would I eventually hit -632? Yes, we would. Okay, so it's in this group. Let's see if we can put it into this group. Whole numbers. Well, notice whole numbers starts at 0 and only counts positive. So can I put it there? Are you shaking your head no? I hope so, because you can't. It has to stay right there. That's where -632 belongs. So all of the sets that it belongs to would be integers and rational. Okay, it's that one and that one, because remember, all of the integers are included in here. So we would say rational, and we would say integers for that. All right, well, how about 0.56 repeating? Now for this part, we can leave the repeating bar there. All right, let's try that. I'll make it a little bit smaller so I can fit it in here. Well, would it fit as a rational number? Well, yes, it would, because it's a repeating decimal. Okay, let's see if we can get it in as an integer. Now, integers, notice there are no decimal values in there. So can I put it with the integers? I cannot. So 56/100ths is rational, and that's the only group it belongs to. And let's do number 10 here, and we will be all done. 21. Okay, is 21, does it count as rational? You can always start on the outside, work your way in as far as you can. It is rational because it terminates. Okay? Is it an integer? Yes, this would eventually go to 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 21. How about whole numbers? 0, 1, 2, 3, 4. It would become a whole number, so it is a whole number. Can we go all the way into natural? 1, 2, 3, 4, 5, 6, 7, 8, 9, 21. Yes, it is. So all the sets it belongs to, rational, integer, whole, and natural. And yes, I would like you to write out the entire word. Sorry if it hurt your hand, but it will help you remember things. It's worth it. Okay, so you work as far inside the circles as you can, and then recognize that it includes all of the categories, all of the sets outside those circles as well. Okay, so some of the numbers will have 4 groups, some might just have 1, some could have 2. The number 0 would go right here. That's only 3. That would be whole, integer, and rational. All right, hopefully that makes sense to you. Bring your notes to class, and we'll see you tomorrow.